beautiful people, and welcome. In today's video, we will be discussing the volume of spheres. Now, when you're thinking of a sphere, think of a basketball, baseball, volleyball, tennis ball, golf ball. So that's what we're going to draw. So a sphere, like I said, is just like a basketball, softball, anything like that. Now, a hemisphere is that shape cut in half. You're going to be dealing with both. When you're dealing with composite figures, most of the time you're going to be dealing with hemispheres, but you should know the formula for both. If you know the formula for the sphere, just cut it in half, and then you know the formula for a hemisphere. All right, so what is the volume of a sphere? And that is, let me change colors here. Volume is equal to 4/3 pi r cubed. Now, if you want to know how we derived that formula, go ahead and Google it, watch another YouTube video. I'm not going to spend time deriving that formula for you. Just trust me, and if you don't, go ahead and do research on your own. All right, and so we're going to divide that in half in order to find our formula for the hemisphere. Now, if you don't want to remember the divide by half, just solve, assuming you have a sphere, and then divide that value by 2 in order to find what your value is for your volume is for your hemisphere, if you want to do that. But let's do some quick math in a thinking bubble. 4/3 pi r cubed. We're going to divide that by 2, or which is the same thing as multiplying by 1/2. So that means I'm going to make sure I'm simplifying. So that means I have 2/3 pi r cubed. And then if you didn't see that, all I did is I multiplied these two fractions together. So I got 4/6. 2 goes into 4 twice. 2 goes into 6 3 times. And that is how I got my 2/3. So let's do volume of a hemisphere is 2/3 pi r cubed. Again, I don't recommend memorizing this formula. Don't worry about it. Memorize the volume of a sphere, solve for the volume of a sphere, and then just divide by 2. Let's start off with an example. A spherical water tank has a diameter of 27 meters. Find the volume of the tank. Step 1 is always identify what you have. They tell you what it is and that you have a sphere. We want to write the volume formula for the sphere. And in this case, you want to solve. Now, they did tell us that the diameter is 27. So we know that if the diameter is 27, the radius is half of that. So we're saying 27 halves, or 27 divided by 2. Now notice that I'm not rounding yet. You don't want to round until the end, okay? So keep it as 27 divided by 2. And then when you're working with this, sometimes things will cancel out and everything. Okay. 4/3 pi 27 halves cubed. And this is where I'm going to take my calculator. Let's see here. And I'm going to type in exactly what I see. I see 4/3 times pi, do not use 3.14, use the pi symbol, times, 27 halves cubed. And now I get this really weird answer because my calculator gives me answers that are exact. I get 6,561 pi divided by 2. Now, when you get an answer like that, read the directions and see if it tells you to round. And I'm trying to get my calculator to round the answer, and it's not wanting to, so give me a second. Oh, you know why it wasn't working? Because I was pressing the wrong number. Wrong button. Okay, so if we are rounding, we are looking at 10,306, what are we doing, meters. And then what are we finding? Volume. Volume is always cubed. Find the capacity of the tank to the nearest liter. So we know what the volume is. Now we want to know that volume in liters. So here's your conversion rate. Again, on your homework, if the conversion rate is not given to you, go ahead and Google that conversion rate. On a quiz or a test, I will be providing the conversion rates for you. So I'm going to erase this so that way I can just use this number. So this is your meters cubed. We're going to multiply by our conversion. Remember, when you're working with conversions, the value that you want left over goes on top. So if I want it in liters, my liter quantity goes on top. What I want to cross out or get rid of goes on the bottom. So my meters cubed goes away. And I'm going to multiply this out. So I'm just going to add, what is it? Move the decimal place 3 zeros to the right. If you want to do that on the calculator, go for it. If you don't want to, that is fine. Just move your decimal. So I have 10,305,995. So here my calculator rounded. So when I used this value, and did my conversion rate, it gave me a decimal number. So you should have something like this. What is our unit of measure? Liters now. Is that cubed? No, because we already accounted the cubeness. Cubeness, that's a cool word. That's cute. Sorry, I make myself laugh sometimes, and that's okay. You'll get used to it. We already accounted for the unit of measure being cubed when we had the meters. All right, you guys. I'm going to pause it just for a second here. Just kidding. No, I won't. All right, let's do another example. Find the volume of the composite figure. So what do we have here? Again, step number 1 is identify your shapes. I have here, if you can see this, that is a, what is that? That is a cone. I'm going to just draw it out so that way you can see that is a cone. And then what do we have here? Remember, that is a sphere, and half of that is a hemisphere. So we have a hemisphere. I can spell. All right, so let's go ahead and write out these formulas. So hemisphere, our hemisphere looks like something like that. I'm not an artist, I don't claim to be. That looks good. Let me redo that. I can do better. Nope. That, but it flipped on its side. All right, what is the volume formula for a cone? It is 1/3 pi r squared times the height. Remember, this right here is just the area of the cone, area of the base. So area of the circle times the height of the cone. Here we have our formula. Again, our formula for the sphere is 4/3 pi r cubed, but we want half of that. So you don't have to remember a separate formula. You just need to remember the formula for a sphere and then divide by 2, whatever that volume is. All right, let's plug some numbers in. 1/3 area of the base. The base is a circle. What do we know about the circle? Do you know the circle radius is, I don't know if you can see that, 5. So we have pi times 5 squared. Height of the cone, this right here. Oh, looks like we don't have it, but we do have a slant height. So I'm going to just draw this out real quick. This is what we have. Again, the height needs to be perpendicular to the base of your figure. So the base is your circle. So the height needs to go all the way down perpendicular to the base. So what do we have? We have 13 here. We have 5 here. We're trying to find this value. It is perpendicular, so we know that it is at a right angle. So we have 5 squared. Remember, hypotenuse is always across your right angle. So we have 5 squared plus x squared is equal to 13 squared. 5 squared is 25 plus x squared 13 squared, I should know this by heart, but we are allowed to use calculators, so you just type that into your calculator. That is 169. Subtract 25. 169 minus 25, that is 144. Ooh. Take the square root, and I get 12. So we're going to plug that in. Again, I'm going to wait to find the total volume just because I want to use my calculator once. Yes, I already used it here, but I'm going to hold off. Let's do the hemisphere volume is equal to 1/2 of 4/3 pi r cubed. We already know the radius is 5. We're going to cube that. And now I'm going to use my calculator. So on my calculator, what I'm doing is I'm typing in 1/3 timesing that, I'm doing this one first, times pi times 25, again 5 squared, times 12. And that gives me 100 pi. This one here, I'm going to do what's in the parentheses first, and then I'll just divide by 2. I have 4/3 times pi times 125, or 5 cubed, and then divide that by 2. I get a volume of 250 pi divided by 3. So how do we combine that? So you can add these together, okay? Because this is pi and this is by pi, you can combine it. So treat pi like a variable. If you have like 5x, let's actually do that right here. If you have 5x plus 6x, what would that be? That would be 11x. It's the same thing here. If I have 100 pi and I have 250 pi, how would that work? So let's go ahead. I'm going to actually box this off. So I have 100 pi plus 250 pi. Again, that's divided by 3. So I'm going to do common denominators. I'm going to multiply top and bottom by 3. So I get 5, 6, 7. Just kidding. You see what I did there? 3, 4, 5. So I have 550 pi divided by 3 as my total volume. Now again, if the directions tell you to round, go ahead and round that. So my total volume is 575.96 centimeters cubed. And I didn't put my units here, running out of space, centimeters cubed. All right, hopefully you got this answer correct. And again, why did we add? Is because we added those two figures together to create the composite figure. We didn't remove anything, we didn't take away. All right, let's do one more example, and then we're through with cone. All right, now we're moving on to example number 3. Find the volume of the composite figure. So we have a cylinder with a hemispherical hole. So they tell you we have a cylinder, we have a hemisphere. So step number 1 is always identify what you have. Step number 2 is write down the formula. So for the cylinder, our volume is the area of the base times the height of the cylinder. For the hemisphere, we're going to take half of the volume of a sphere. All right, so cylinder, here it is. What is our base? Our base is a circle. So what is the area of the circle? The area of the circle is pi r squared. And we're going to do the height of the cylinder. So let's look here. Here is our circle, or our base. It tells us that the diameter is 7. So the radius of that should be half of 7. So what is half of 7? Is it 3.5? Sure is. So we're going to say pi times 3.5 squared times the height of the cylinder. So whenever you have this symbol here, that tells you that this unit of measure, or this measure, is perpendicular to the base. So we have 7. Now let's go over here to the hemisphere. We have 1/2 times 4/3. That's a weird looking 3. I'm going to erase that. That looks like a 5 to me. 4/3 pi. Again, the radius is 3.5 cubed this time. Now we take out our calculator. I'm going to do the 3.5 squared first. I'm going to multiply that by 7, and I'm going to multiply that by pi. So I get 269.392. Do the same thing here. I have 4/3. Let's do the 3.5 cubed first. Then I'm going to multiply by pi. Then I'm going to multiply by 4/3. And lastly, I'm going to divide by 2. And I get 89.797. And again, what's happening? We are removing that hemisphere. So I'm going to say 269, that's a 3. 269.392 minus 89.797. So let's subtract that. Woo! Guys, I'm having trouble with my calculator today. 269.392 minus 89.797. There it is, 179.595. What's our unit of measure? Inches. What are we trying to find? Volume. Volume is always cubed. All right, guys, that's it for the spheres. I hope you enjoyed this video. As always, if I made a mistake, I apologize in advance. Let me know where that mistake happened so I can learn from it. As always, thank you so much for watching. I appreciate you watching my videos. I will see you in the next one. Have a great day. Bye.